Hi students, this is AJ sir. Let's study 9th standard ICSE Math, chapter 12, Midpoint Theorem, exercise A. Also, to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. The midpoint theorem states that in a triangle, that is ABC or any other triangle, if D is the midpoint of one side and E is the midpoint of the other side, and if you join them, then DE will be parallel to the base BC always. Not only that, DE will also be half of BC. That means if BC is 10 centimeters, DE will be 5 centimeters. That's because D is the midpoint of AB and E is the midpoint of AC in triangle ABC. This is called the midpoint theorem. And the proof has to be practiced just like you will practice all the solved examples. We use congruency here, so it's pretty easy. The converse also has to be practiced for homework. This can come in exam. The converse states in a triangle ABC, if D is the midpoint of AB and DE is parallel to BC, the base, then automatically we can say that E is the midpoint of AC and that DE is half of BC. So in midpoint theorem, it is given that this is the midpoint and this is the midpoint, and we conclude that this is parallel to this and this is half of this. In converse of midpoint theorem, it is given that this is the midpoint and this is parallel to this, and we conclude that this is the midpoint and this is half of this. So two things are always given and two things we can conclude as per these theorems. So this entire exercise is based on this concept, which is pretty simple. We'll do the sums which are ticked. Mark the following sums as IMP: the 6th sum, the 9th sum, the 12th sum, and the 16th sum. And some cancellation in question 5. You just have to do Roman number 1 for homework. Roman number 2 and 3 can be cancelled because it is of the same type as Roman number 1. So just trying to reduce your homework here. Second sum. Prove that the figure obtained by joining the midpoints of the adjacent sides of a rectangle is a rhombus. Now this is geometry. Here the given is not given, so you'll have to write the given. First, try to draw the diagram. See if you can figure out what the diagram would look like, because only if you get the right diagram will you be successful in solving the sum. So that's the most important step in geometry sums, without diagrams given in the question. So it's like this. So write the given. In rectangle ABCD, PQRS are the midpoints of the respective sides. To prove that PQRS is a rhombus, which means we have to prove that PQ is equal to QR is equal to RS is equal to SP. Because if all sides are equal, that's a rhombus. Constructions, draw the diagonal. Now, first let's take triangle ADC. ADC. In this triangle, S is the midpoint and R is the midpoint in triangle ADC. So if I have two midpoints, which is already given in the question, then I can apply the midpoint theorem to triangle ADC, and I can say SR is parallel to AC and also that SR is half of AC. Midpoint theorem. Similarly, I can say it in triangle BCA. See, even here P and Q are the respective midpoints, isn't it? So again PQ will be parallel to AC and it will be half of AC. So if SR is half of AC and if PQ is half of AC, that means SR is equal to PQ. So I've proved opposite sides equal. Now when you solve it, this is the way you have to write the statements. First you have to write the two pieces of information given. Then only we can use a midpoint theorem. And notice I didn't write SR parallel to AC because I didn't need that in the sum. But even if you do write it, it's okay. And I use similarly here. No need to write the whole sentence again for triangle BAC. I can just say similarly PQ is half of AC, and from these two statements it follows that they are equal. Next, in triangle ADB, S and P are the respective midpoints. That means SP will be half of DB because DB is the base of the triangle. So SP is half of DB, and similarly RQ is half of DB. So again, by the same logic, SP will be equal to RQ. So I just proved opposite sides equal, but that's not enough. I have to prove the adjacent sides equal as well. If you see, SR is half of AC and SP is half of DB, but AC is equal to DB. They are diagonals of a rectangle. So if DB and AC are equal, then SR and SP will also be equal. If diagonals are 10-10 each, then SR and SP will be 5-5 each, half-half. So I just proved the adjacent sides equal. That means now all four sides are equal. And once we prove all four sides equal, it's a rhombus. Notice how I always give Roman numbers to the statements so that I can use them in my reasons ahead. You could even number them in the margin, all the statements, and use those numberings in your reasons if required. Now in the fourth sum, the diagram is given, so no need to write the given. We have to prove that PR is half of the sum of AB plus CD. Here, in the question they have mentioned that P is the midpoint of AD, and they have also mentioned that PR is parallel to AB. That's what they have mentioned. So we'll use converse of midpoint theorem. In triangle DAB, if P is a midpoint and PQ is parallel to AB, then it follows that Q will be the midpoint of DB, and also that PQ will be half of AB. Converse of midpoint theorem. Next, in triangle BCD, it's an inverted triangle, but in triangle BCD, Q is the midpoint and QR is parallel to DC. DC is the base here. So if I have a midpoint and if I have a line passing through the midpoint parallel to the base, what follows? That R is also the midpoint of BC. Again, converse of midpoint theorem. So see, here P was given as midpoint, but I proved that Q is the midpoint, and now using that I'm proving R is a midpoint by converse, and also QR will be half of DC. So I proved PQ as half of AB and QR as half of DC. If you add these two statements, what do you get? PQ plus QR is half of this plus this. And by the way, PQ plus QR is PR. That is what was asked to be proved. So using the two triangles, I proved what was asked. Using converse of midpoint theorem twice. Now this is an important result. It means that in a trapezium, yes, this is a trapezium because two parallel sides and two non-parallel sides. In a trapezium, if we have the midpoint of the non-parallel sides, then the line joining the midpoints is always half of the sum of the parallel sides. And this is the result which you will use in question number 5 to calculate. So you will directly say that Mn is equal to half of DC plus AB, property of a trapezium, as M and N are the respective midpoints given. So directly write the formula and then substitute these values to get the value of Mn. Next, the sixth sum. That's an IMP sum. The diagonals of a quadrilateral intersect at right angles. Prove that the figure obtained by joining the midpoints of the adjacent sides of the quadrilateral is a rectangle. So again, a proving sum. Come on, draw your diagram. Let's see if you can figure out the right diagram. Here the given is not given, so we'll have to mention the given. Yeah, quadrilateral. Purposely I'm not shaping it like a rectangle or a parallelogram so that it's very clear to me that it's a quadrilateral with no special features. Otherwise often we just assume something and get the whole sum wrong. What is given is that the diagonals are perpendicular to each other. I have also marked the midpoints as P, Q, R, S. Write all the given. If you don't write given, you lose marks. No construction here. Everything was already mentioned in the question. I have to prove PQRS is a rectangle. So first plan your strategy. I'm going to prove opposite sides equal, which is very simple. PQ equal to SR and SP equal to RQ. Do you know how to prove that? Well, we've done this in the previous sums, right? In triangle DAC, S and R are midpoints, means SR is half of AC. Similarly, PQ is half of AC. So SR is equal to PQ. And similarly, SP is equal to RQ. Just use similarly, no need to do the whole thing again. So I have proved the opposite sides equal. But that doesn't mean it's a rectangle. It means it's a parallelogram. I need to prove any one angle as 90 degrees. Say this angle, if I can prove it as 90 degrees, then the sum is done. Then obviously automatically all angles will be 90 and it will be proved as a rectangle. But how do I do that? Well, we know that the diagonals are perpendicular to each other. Now using midpoint theorem, we would already have mentioned that SP is parallel to DB. Midpoint theorem. Similarly, SR is parallel to AC. Again, midpoint theorem in triangle DAC. So, if this is parallel to this and this is parallel to this, but this is perpendicular to this, it follows that this is perpendicular to this. So I proved this is 90 degrees. There are other ways as well. You can say by corresponding angles this is also 90, and by alternate angles this is also 90. That way is also fine, whatever suits you, but write proper statements and reasons. This is how I have mentioned, with all the Roman numbers also mentioned. Next, the eighth sum. Here the diagram is given, which makes it so easy. It's a quadrilateral and the midpoints are given, and also AD is equal to BH. We have to prove that EFGH is a rhombus. Means we have to prove EF is equal to FG is equal to GH is equal to HE. So think about it. How would you prove it before I start teaching it? Use your mind. Okay, here we go. First, we take triangle ADB. ADB, visualize it. If you want to draw it separately, do that. In ADB, E is the midpoint and F is the midpoint respectively. E is of AB and F is of FB. That means EF is half of AD. EF is half of AD. Okay. Similarly, in triangle ABC, I can say that, so this was half of AD. Now I can say that EH is half of BC. In triangle ABC, EH is half of BC. Midpoint theorem, because E and H are midpoints. It's given. But midpoints of what? You have to mention that. Midpoints of blah and blah respectively. Always mention it that. So this is half of this and this is half of this, but DA is equal to BC, given. That means EF is equal to HE. Okay, now let's take triangle ACD. Yeah, ACD. H and G are respective midpoints. That means HG is half of AD. HG is half of AD, which is interesting because even EF was half of AD in triangle ADB. And now we are saying that HG is also half of AD in triangle ACD, again by midpoint theorem. And similarly, FG in triangle DBC, if you want to draw it separately you can. In triangle DBC, FG is half of BC, whereas earlier I had said that HE is also half of BC in triangle ABC. So what it means is that all four sides are now equal. I have used midpoint theorem 4 times. Of course, I didn't make the statements 4 times. I just used similarly everywhere. But the logic is EF as well as HG both are half of AD. HE as well as GF both are half of CB. And also DA is equal to CB. So if you combine all these statements, it's clear that all four sides are equal, and so it's a rhombus. These are the statements. Now the 9th sum is IMP. The diagram is given. It's a parallelogram. P is the midpoint of DC. Now obviously we'll do a construction out here. We'll draw the diagonal DB. So in triangle CDO, P is the midpoint of DC. P is the midpoint of DC. Okay. Now we know that in a parallelogram the diagonals bisect each other. That means CO will be half of CA. CO is half of CA. Okay. But in the question they have also mentioned that CQ is 1/4 of CA. Now if CQ is 1/4 of CA and CO is half of CA, that means CQ is half of CO. CQ is half of CO. That means Q is the midpoint of CO. So in triangle CDO, P is the midpoint, Q is the midpoint. So by midpoint theorem, this is parallel to this. And now in triangle CDB, P is the midpoint of one side and PR is parallel to DB. So what follows? R is the midpoint of CB by converse of midpoint theorem. In a triangle, I have one midpoint, I have one parallel. That's it. Automatically the second point, this point is also a midpoint. That is Roman number 1. And converse of midpoint theorem also says that PR will become half of the base DB. That is PR is half of DB. That is Roman number 2. Done. Here are the statements. Now the 12th sum. In trapezium ABCD, AB is parallel to DC. P and Q are the midpoints. This seems to be quite challenging. It's like this. We have a trapezium. We have two midpoints. Join them. Prove that if I extend this here, prove that this is the midpoint of this line. And more interestingly, the Roman number 2 prove that this line is parallel to AB. We have to prove them parallel. For example, in this sum, what if M and N are midpoints and we have to prove Mn parallel to AB. Now if this was a triangle and M and N are midpoints, then easily we can say that Mn is parallel to the base and Mn is half of the base. But it's not a triangle, it's a trapezium. So in exam, I might just ask you Roman number 2 directly and yet you might have to solve Roman number 1 to prove Roman number 2. I said might because there is another method which you will study in the B exercise called equal intercept theorem, which I'm not getting into right now. Let's solve 12th sum with the midpoint theorem. So if you read the question carefully, the diagram looks like this. We have to extend BP till point E, and now I have to prove P is the midpoint of BE. That means I have to prove PB is equal to PE. I have to prove that. So I'm going to use congruency here in triangle APB and triangle DPE. While proving congruency, the corresponding sides being in the correct order is vital. So what do we have here? I have AP is equal to PD given. Then I've got vertically opposite angles and I've got alternate angles equal. But whenever you mention alternate angles, please mention the parallel sides also. So which test is that? SAA test. So that means PB is equal to PE CPCT. That means P is a midpoint of EB. That's Roman number 1. Don't forget to write Roman numbers, sub-question numbers. And this was very crucial to prove Roman number 2 now, because now in triangle BEC, P is the midpoint of BE, proved. Q is the midpoint of BC, given. So what follows? PQ is parallel to the base EC by midpoint theorem, but EC is parallel to AB. That means PQ is also parallel to AB. That is what was required to be proved. So these are the statements. Now the 14th sum. Come on, draw the diagram on your own. It's an easy sum. There's a triangle, 2 midpoints are given and 2 Roman numbers. So D is a midpoint, F is a midpoint, and FE is parallel to DB given. Prove BDFE is a parallelogram. First of all, BD is parallel to FE is already given. I just have to prove DF parallel to BE, and then it will be automatically a parallelogram. But how do I prove DF parallel to BE? Midpoint theorem. In triangle ABC, always mention the triangle for the midpoint theorem. D is a midpoint, F is a midpoint, so obviously DF is parallel to BC or BE. DF is also half of BC, but that's not required in this sum, so I'm not mentioning it. But even if you do, it's okay. So that's how we have proved them to be a parallelogram. Next, they've said that EF value is 4.8. So how much is AB? Now in triangle CAB, F is the midpoint of AC given, and also FE is parallel to AB given. So by converse of midpoint theorem, it follows that E is the midpoint of BC, but that's not important for this sum. But it also means that EF is now half of base AB. EF is half of AB by converse of midpoint theorem. So if this is 4.8, AB will be 9.6 centimeters, and the sum is over. And now 16th sum, IMP sum. In triangle ABC, E is the midpoint of the median AD. That means D is also the midpoint of the base. And BE produced meets AC at point Q. So what would the diagram look like? I'm guessing something like this. So this is E, and this is D, which is also the midpoint. A, B, C, BQ. The question is, prove BE ratio EQ is 3:1. So that means if this is 3x, then this will be x. That's what we have to prove. So think about it. Any guesses? How will you solve it? Come on, think hard. Try different theorems that you've learned in the past. Okay, now I'll tell you what to do. Step 1. This is a trick. When they say that this is 3 and this is 1, what if I draw a line here or make a point out here, let's say P, and then it's easy for me to break it up into smaller parts, and if I can prove this is 2x and this is x and this is x, then this is 3x and x automatically. So there's a construction involved here. PD, draw PD parallel to AC. PD parallel to AC. What's the use of that? Well, now in triangle BCQ, I have D as the midpoint. Okay, and you know that this is a midpoint theorem chapter. So for midpoint theorem or for converse of midpoint theorem, we always need two things. They have already mentioned D is a midpoint because AD is a median. But you know that just one piece of information is not enough. I need one more thing. In a particular triangle, by making this construction, now I have that second piece of information. PD is parallel to AC in triangle BQC. Now I can say that BP is equal to PQ because P becomes the midpoint of BQ. P is the midpoint of BQ. Now focus on these two triangles and prove them congruent. We've got DE equal to EA. We've got vertically opposite angles and also alternate angles because this is parallel to this construction. So which test is this? ASA test. So that means PE is equal to EQ. So if I assume EQ as X, PE will also be X. Great. But I have to prove that BE is 3X. How do I do that? This is X, this is X. Okay, you know BP is equal to PQ, right? BP is equal to PQ. We just proved it earlier. And PQ is 2X. That means BP is also 2X. That means PE is 3X. And that's what was my target. So BE is 3x and EQ is x. That means BE ratio EQ is 3:1. And these are the steps.